salt solution, and the example of electrolytes are salt solution, strong acids, strong acids, strong alkalis. There are so many examples. Later on, I will check my laptop, then we'll share with you some notes about these topics. Here we can, and probably you can also get few examples from your textbook or from that book which you guys are following for your exam preparation.
Okay.
In electrolytes are those liquids compound which when molten or when dissolved in water conduct electric current. And one of the most beautiful example of electrolyte is sodium chloride, which mostly we use in our kitchen.
Yes.
The sodium chloride is an example of electrolyte. And then discussing about non-electrolyte is opposite to electrolyte. Non-electrolytes is a liquid which does not allow the current to pass. It is a liquid, or we can say it is a substance. It is a liquid, or we can say it is a substance which does not allow the current or electricity to pass. And the example of non-electrolyte are distilled water. Distilled water is a type of water which does not contain any ions. Distilled water is one of the example of non-electrolyte. Then alcohol is another example of non-electrolyte. Then paraffin. Paraffin is another example of non-electrolyte. And then organic solvents. Organic solvents means such as ethanol, such as sugar solution. If we dissolve sugar in water, it is a sugar solution. Tetrachloromethane, CCl4, tetrachloromethane, ethanol, alcohol, ethanol. These are the examples of non-electrolyte. Okay, now I am going to erase this. If you want to take a screenshot, then you can take. If you want to ask a question, you can ask that question from me too. Do you want to ask a question?
Yes, I wanted to ask a question about graphites and diamonds.
Yes.
Is it true that the giant structures?
Chloride, because we have mentioned sodium chloride. NaCl is the formula of sodium chloride, and we have mentioned sodium chloride is an electrolyte. This is an experiment which we can also performed in our home possibly, and the experiment is like this. There is a cell, or we can say there is a battery, and this is the battery, and one wire is connected battery, and this wire is connected with a bulb. This is a bulb. Then this wire is connecting here, and this is a glass, or this is a beaker full of water, and the other end of battery is connecting at this point, and this glass is full of water, Okay, then make another diagram similar to this diagram. Take a battery, connect one end of the battery with a bulb, and then taking this wire to that position. This is again a glass, and by joining this end of battery here at this point, this glass is again full of water. And both glass have plenty water, sufficient water. And this is bulb. This is bulb, bulb, and this is bulb, bulb, which can give us light. This is glass number one, and this is glass number two. Suppose, uh, suppose we add sodium chloride in glass number two. We add sodium chloride in glass number two. We add a spoon of sodium chloride in glass number two, and glass number one, glass number one just have pure water. So when we turn on the switch and current start flowing from the battery to this wire, then what do you think should this bulb produce light?
No.
My question is, there are two bulbs, one in glass here, one and anode. These are because in electrochemistry, if we are familiar with the basic terms, then we can build our concept. These basic terms are very important, and we must familiar with anode and cathode, and what is oxidation, where it happened, and what is reduction, and where reduction happened. Do you know about oxidation?
Yes.
What is oxidation?
Oxidation is the gain of oxygen and reduction of hydrogen.
Yes.
And then in oxidation, there's loss of electrons.
Loss of electron. Good. Okay. All right. So oxidation is loss of electron. Oxidation is loss of electron. Loss, LOSC loss. I forget the spelling of loss. LOSC loss. LOSC loss, right?
LOSS.
LOSS. All right.
Yes.
All right. That's great. Loss of electron. And reduction
Increase.
is but we will focus about electron because in electrochemistry we just have to deal with gain of electron and loss of electron,
Okay.
and reduction is gain of electron. These are these are oxidation and reduction. But the point is, mostly students get confused about oxidation and reduction. They get confused. Where is loss of electron happened and where is gain of electron happened? They get confused. Probably they get confused that in reduction loss of electron and in oxidation gain of electron. They get confused with both these terms. But you are a quite brilliant student, and you are super genius student. You clearly remember what is oxidation and what is reduction. Mostly students get confused in case of oxidation and reduction, and so there is a trick to remember oxidation, and there is a trick to remember oxidation. And I use this trick to teach my students, and the trick is oil.
Rig.
Right? Oil.
Rig.
Oh, excellent, Rig. This trick is also working in Zimbabwe.
Yes.
This is a universal trick. It means this is a universal trick. So your teacher told you about these tricks?
Yes.
Great. Oxidation is loss. Oxidation is loss. Loss of what? Loss of electron. And
Electrons.
reduction is gain. Gain of what? Gain.
Of
Reduction is
electrons.
gain. Gain of electron. So, all right. Now, so there are two electrode. Electrode is basically is a rod like material which pass current into the solution. Electrode is a material which carry electricity into the solution. Electrode is a material. Electrode is a material. Electrode is a material which carry current into solution. Now the question is where reduction happened and where oxidation happened. Cathode, reduction happened or oxidation happened at cathode? What do you think?
That's where I get confused.
Ah, yes.
Yes.
There is another trick to remember what takes place at cathode and what takes place at anode, and that trick is red cat. Red
Yes.
cat. It means reduction happened at cathode. So oxidation happened at anode. Oxidation at anode. At cathode, always remember at cathode, reduction happened. Reduction takes place at cathode, and we can remember it by red cat.
NX. NO.
And what about anode? How you? What about anode?
NOx.
N NOx.
Ox.
Ah,
Yes.
NOx. I think something like that. I forgetting it. Okay, NOx. NOx. Oxidation at and reduction at cathode.